Hey everybody, Hollis Darby here with ArmySignalTraining, and in this training video we're going to be going over DHCP. Now, you're going to have to bear with me a little bit on this video. I'm using a new recording suite called Camtasia 8, and this is the first video I'll be producing with it, as well as a new pen tablet by Wacom. So when I start doing my illustrations, it might look like a 5-year-old's drawing on the pad. That's definitely me. My penmanship's not great to begin with, and trying to digitize it is not seeming to help me very much at all. But without further ado, let's go ahead and get started. So what is DHCP? DHCP stands for the Dynamic Host Configuration Protocol, and is used to dynamically send Layer 3 information in devices, that of like a computer, a printer, an IP phone. DHCP operates on 2 port numbers, which are UDP port 67, which it uses to listen on, and 68, which we use as the source. So how does it work? DHCP works by dynamically providing an end device with Layer 3 IP information. As a computer comes online, or when directed to do so, the PC will send out a DHCP discovery. I want you to remember this part. A DHCP discovery packet, utilizing the Layer 2 broadcast address of all Fs. Because remember, at this point, we're requesting an IP, so we don't yet have one. So all of this is being done in the Layer 2 domain. So we're using a Layer 2 broadcast, which is the one of all Fs. And we're sending it to a destination port number of UDP 67. So my computer sends out a discovery at this Layer 2 broadcast of all Fs to the destination port 67. If a DHCP server hears this packet, the DHCP server will respond with a DHCP offer, offering up an appropriate IP address to the end device. Once the end device receives this packet, the end device responds back to the DHCP server with a DHCP request packet to formally request the Layer 3 IP information. After the DHCP server receives this formal request from the end device, the DHCP server will respond back with a DHCP acknowledgement packet to inform the end device that the IP address is officially theirs. Big things to take note of here are simply the order in which this is happening. First thing, client sends discovery packet. Sends it using this Layer 2 broadcast onto a destination port of UDP 67. Within that Layer 2 broadcast domain, if there is a DHCP server, it's going to hear that and it's going to reply back with an offer. That offer, once it's received by the computer, he's going to look at it and say, yep, I like it. And then he's going to send back a request to formally request to have that from the DHCP server itself. Once the DHCP server receives that request, he's going to say, okay, you want it? You got it. And he acknowledges that that IP information is now theirs. Now, this isn't going to be permanent, or it could be permanent, but we're not going to configure it to be permanent because that's going to lead us into one of the topics we'll be talking about today, and that is called leasing. So what are our objectives here? We're going to cover static versus dynamic addressing. We're going to go over configuring exclusions, configuring pools, and also, as I alluded to a second ago, talk about leases. So let's start with static versus dynamic addressing. What is this? Static addressing is where you, as the administrator, manually go into your network, each end device, and you configure the IP address, the subnet mask, the default gateway, the DNS. You go to each computer and you configure those manually. That is what static addressing is. To give you an example, that is in the Windows environment, I would pull up my network connections here. I would go to the properties of my local connection, go to IPv4. Right now, when it says obtain an IP address automatically, what that is telling me is that is representing DHCP. This right here represents to use DHCP. To statically assign something, we want to use this option here. Use the following address. We want to predefine the address to be used. So what I would do is simply go in and click to statically assign and give it an IP address, 192.168.1. 50. Provide a subnet mask, provide a gateway, whatever. You see where I'm getting at? You have to manually define these parameters for it. But that's not what we want to do. That defeats the whole purpose of this video. We're here to cover the dynamic host configuration protocol to do this dynamically. So I'm actually going to go back to the top option here, obtain an IP address automatically, and allow DHCP to do its magic after we set up the configuration within the router. But that's how you would statically define it. Okay, so that covers static. Now what about dynamic? To cover dynamic, we're going to have to go into our device. So this is the topology that we're going to be working with. So I have a couple things set up here. Grab my pin. This is going to be my desktop that I'm on right now. I am connected. Well, I'm not connected to Fast Ethernet 0/1 yet, but I will be here shortly. But that's going to be the interface that we're connected to. It's already set up and as an access port, and I even have Spanish report fast turned on that interface. This is my trunk. My trunk link is. This is my trunk. My trunk link is configured. And this is the network that we're going to be dealing with here on gig 0/0. So all that's already been pre-configured. The only thing that we need to do is go into the router and set up our DHCP. Now, the first thing that when we go to configure DHCP that we want to do is, the first thing we want to do is set up our exclusions, or as they refer to it in Cisco as excluded addresses. So the reason why is because if I leave it like it is now, look at my default gateway. 10.10.1.1. If I turn this DHCP on here, it's going to start offering out IP addresses. So, he sends the discovery, the response comes back, or I'm sorry, the offer. The offer is going to be for 10.10.1.1. And that's kind of scary, because 10.10.1.1 is already taken, right? So we actually want to exclude our default gateway. And what I would recommend, depending on how much IP space you have to work with, is exclude at least 10 IP addresses. That is helping you plan for future growth. Let's say you add a network printer to your network topology, or a digital sender or something of that nature, where you're mapping other end devices to it. You don't want that IP address to change if its at least time expires. So how about we allocate 10 or so addresses and exclude them from DHCP, preventing the server from allocating out those IP addresses. So I'm going to pull up our terminal here to get started. See, I'm in the router. The first thing I'm going to do is set up my exclusions. So I'm going to go global configuration mode and simply type in IP DHCP excluded addresses, and I'm going to exclude 10.10.1.1. Now I can do just one IP address, or I can do a range of IP addresses, and I could put this statement in there multiple times. Like I can put this, exclude that address, exclude .1 through 10.10.1. We'll do 10. And you see what I'm saying? I could keep going on. Let's say I need to exclude 192.168.1.1. You can use this command several times. If I do a show run section IP DHCP exclude, as you can see, it's going to take all of them. So it's not like it's overriding itself. So if you have to exclude several different blocks of IP addresses for whatever reason, you can. So obviously I have my exclusions set up. I wanted to prevent it looks like I had a residual one in there, but let me go ahead and take that out. There we go. But I'm excluding 10.10.1.1, 10.10.1.1 through 10.10.1 through .10, and 192.168.1.1, which we really don't need for this topology. Next thing I'm going to do is set up my pool. That's actually really simple to configure. I'm simply going to type in IP DHCP pool, and it's going to ask me to give it a name. When you see this right here, word, it's literally asking you to type in a word. So I like to do all caps when it asks for something like that, because a lot of times these things are case sensitive. So I'm going to just say data. It could be anything. It could have been Hollis or, Cisco or whatever you want it to be. Next thing, as you can see under here, now that I'm under the DHCP configuration, I have a lot of options here Do not let this intimidate you, because a lot of this we're not going to mess with. The first thing we're going to set up is the network. And I'm simply going to type in the network that we're working with. Well, if I refer back to this slide, we're working with 10.10.1.1 with a /24. So the network address is 10.10.1.0. So that's all I'm going to type in there. So 10.10.1.0 with a /24, which is 255.255.255.0. What's really cool about the network command in the DHCP is it allows you to use CIDR notation. Not a lot of commands in Cisco, as of yet, allow you to use the CIDR notation, but since it allows me to, I'm going to. This is what configures my pool. So going back to our slide over here, as far as our objectives, when I configure that network command, that is, we've configured our exclusions, but the configuring pool, that is what configured the pool. Next thing I need to do is define what is the default gateway. And that is done with the default router command, default-router, and that is 10.10.1.1. And lastly, I need to give it, or not lastly, I need to give it some DNS information so it can resolve fully qualified domain names to IP addresses. And I'm going to use 8.8.8.8 followed by 8.8.4.4. Now, in this command, be wary, because I've seen this done by people several times, and it really gets them in a jam sometimes. The first number here, first IP address, is your primary DNS server. The second one is your secondary DNS server. If I do this, which is what I see happen a lot, and then try to enter the secondary, look what happens. It overrides it. So when you're typing this in, it's your DNS server followed by your primary DNS server, then your secondary DNS server. Enter. And the last thing we're going to cover is the lease time. Now, your lease time is really going to be determined by kind of your environment. For example, if I was in a coffee shop, I would have my lease down to 1 day. That way, after 12 hours, the DHCP server is going to try to contact the end device to talk about renewing the IP address, asking the device if it still needs the IP address, if it needs to keep it longer, what have you. So depending on your environment and how much IP space you have to allocate out, I would trim this down. Typically, what I tend to do, in the pseudo production networks that we work on, I tend to do like 3 days. So every 3 days, or at this point, every 1.5 days or 36 hours, I'm asking the DHCP server to say, hey, computer, do you still need that IP address? Computer responds back, yes. He says, okay. And that just keeps going. Now, at which point, let's say I go on vacation for a month. Obviously, I don't need that IP address anymore. So after 3 days, 36 hours, the DHCP server asks the computer, do you need it? It gets no response for another 36 hours, and then it says, fine, I'm taking the IP address back. Helps conserve IP space depending on how many IPs you actually had to give out. Now, with the /24, that gives me a lot of IPs to give out, but maybe I don't have a /34. Maybe I have a /28, and I don't have that many people, IP address to dynamically allocate out. So the lease command is what controls how long they're able to keep the IP address. This isn't saying that, well, at 3 days I'm taking it back and you got to start all over. No, it's just if it doesn't hear back from the end device within 3 days, it's going to take the IP address away. If the device is still using the IP address, it will allow it to keep it. So it's not like kicking it off the network after 3 days. But that's what the lease command does. And that's all there is to configuring it. Let me do a show run pipe section IP DHCP so we can kind of cap on what we did. So the first thing we did was set up our exclusions, which was very important. So go down here. This is where we establish what we do not want the DHCP server to give out. We created our pool and we named it data. I can't even draw a straight line in this thing. It's called data. This is what really defines the pool. This is the default gateway. So this is the gateway. And this is the DNS servers. And we're giving it a lease of 3 days. So when I plug my computer in, this is what's going to happen. My computer, as soon as I plug it in, it knows it doesn't have an IP address, so it's immediately going to send out that broadcast of all Fs to port UDP 67. Being that this router is our DHCP server, it's listening for that, and when it gets that discovery packet, it's going to respond back with an offer. Once the computer receives the offer, it's going to send back a request, and then the DHCP server, the router in our case, will send back the acknowledgement. I know I keep repeating this, but this is what I really want you to take away from this video is this is everything that's happening in the background. So if DHCP is not working for you for whatever reason, you could hook up Wireshark, do some spanning on your switch port interfaces and kind of troubleshoot as to what's going on. I know some of that might have been kind of a little gibberish to some of you, but we'll go into some of these advanced troubleshooting procedures later. But let me go ahead and do an IP config on my computer here. Ethernet adapter is no media, so I'm going to go ahead and plug in my computer here, and voila. As soon as I plugged in my computer, I got an IP address right here. As you can see, has the IP address, which is within the proper range, the subnet mask, and the default gateway, all of which we've pre-described in our configuration inside of the router. Now, if I want to get more detailed information on here, I would simply do ipconfig-all, which would give me the remaining information like the DNS servers that were configured and whatnot as well. So let's say I'm getting a bind here. I can do an ipconfig/release, which will release that IP address, and do an ipconfig/renew, renew, which would probe that whole discovery process all over again. So in the background, it's going to, bam, just like it just did. It's going to go through that entire, discovery, offer, request, acknowledgement process again and get a new IP address. Wonderful. And if I go to the router, I can do a show IP DHCP bindings, or binding, and see here what it's allocated out. In my case, only one, but 10.10.1.22 is what it did. In fact, allocate out. This is the MAC address of the device, when it will expire, and what type it was. Automatic is DHCP. Well, and that is DHCP in a nutshell. I will be doing a follow-on video on some of the advanced features of DHCP using things like a Windows server and the IP helper command. But if you have any questions or comments, I would love to hear them in the comment section below. And thank you for all your support and have a great day.